Ladies and gentlemen, welcome to sqadia.com. My name is Mohammad Osama, and today we are talking about interpretation of diagnostic tests and laboratory statistics. The topic that we're going to cover today is sensitivity and specificity, in which we're going to talk about the definitions and descriptions of sensitivity and specificity and how can we calculate sensitivity and specificity. So sensitivity and specificity describe quantitatively the ability of a test to correctly identify a population of a person with and without a disease. These values or these terms are independent of the prevalence and incidence of the disease, in contrast to the positive predictive value and the negative predictive values, which are actually dependent on the prevalence and incidence of the disease. So let's start off with sensitivity. So sensitivity as the measure or sensitivity measures the extent to which a laboratory test or an outcome measurement is positive in patients. That is, it correctly identifies person with the appropriate disease. So if there is a high sensitivity for any outcome measurement or laboratory test, so it is going to be positive for a greater number of people. It can even detect a very small chance of being positive for any individual or case. Ideally, sensitivity should be very high when a procedure is used as a screening test, because it is desirable to identify as many as possible people with the disease, because greater the sensitivity, greater the probability of giving a positive result. The point of maximum sensitivity is the lowest test value that detects subjects with a disease. So for example, if there is a range and we say that if the range is this to this for someone to be positive, so the sensitivity would be maximum at the lower value or the lower test value for that test or an outcome measure. In order to calculate specificity, we can calculate it by true positives divided by true positives plus false negatives multiplied by 100. So that is actually how we can find out the specificity. Whereas if we talk about the positive predictive value, it was true positives divided by true positives plus true positives divided by true positive plus false positives. But here it is true positives divided by true positive plus false negatives. Now specificity. Specificity is actually opposite to sensitivity, and it measures the extent to which a laboratory test is negative in patients. That is, it correctly identifies persons who do not have the appropriate disease. So higher the specificity, greater is the chance for the test result to be negative and excluding the individual or case from being positive for any disease. Ideally, the specificity should be very high when a procedure is used as a confirmatory test instead of a screening test, because it is desirable to exclude as many as possible people as possible who do not have the disease, because it would not be favorable to identify someone as positive for having a disease which that person does not have. The point of maximum specificity is the highest test value in contrast to the lowest test value for the sensitivity. So the point of maximum specificity is the highest test value that correctly identifies all the subjects without a disease. So the formula to calculate the specificity is true negative divided by true negative plus false positive multiplied by 100. Whereas if you remember the predictive negative value, then that was true negative divided by true negative plus false negative multiplied by 100. So that was all about sensitivity and specificity and how to calculate sensitivity and specificity for a specific outcome measurement or lab test findings. And stay tuned for more lectures like this. I hope it was beneficial for you. So keep on watching sqadia.com.